Hi guys, please like button, push subscribe button, leave a comment and share this video among the world. And um, right now I have two things. So first thing is how processor actually is created, and the second thing is remember we did a server and I wonder if I can um, create the server and I can connect with my devices, home devices, to this server and watch videos from this server without actually installing them and that stuff. So let's begin with this one because it's more obvious. Okay, so first of all, let's start this server. So how I did it? Um, Python 3. By the way, I don't see anything. Python 3 minus m http d server http. Yeah. Okay. Now I have this. Oh, nice! It's opening in my new browser called Firefox Nightly. Nice. Anyway. Yeah. So now from here I see like a lot of stuff. But if I will press, for example, this one. Wow,
Okay,
guys,
guys, hi everybody. So
wow,
you're
it's
on my channel,
rendering.
so please
Wow, it's
press.
amazing, guys. Okay, so now let me just check my uh my IP and I will just try to connect directly. So let's check it. IPA. So I have this address. Okay, so let me just grab my phone and try to go to. I have an iPhone, so um I will just go to Safari and just type this IP 192.168.50.6, and I think I will try to do it without a port. Okay, and it cannot open. And okay, maybe I'll add HTTP. Okay, it also did not work, but I'm running on some port, right? I'm running on 800, right? So let's try 800. Yeah, guys, look at this. Yeah, so I get the same. I get all my files on the on my computer. Nice, nice, nice. Wow, look, and get requests are coming. Nice, nice. And now let's check out the video. Well, I don't know. It's too long actually, so maybe it is actually downloading the whole video. This is not very good. Yeah, you see, basically in here we can see that I requested like get request and my video. So indeed it is downloaded and there is a sound. Yo, so today we are going to watch Mozilla Firefox. But actually this video is one hour long, so it's pretty good. I mean, and I don't know where it stores. I guess it stores in the browser. Okay, I closed that video and open it again. So maybe it is good because it stores temporarily. Okay, guys, so it's good. Yeah, it's perfect. It's really perfect. I mean, I can download some movies on my PC, and when I want, I will just use my because we have a laptop, and I'll just go from there to my PC and just watch a video. Um, Nice, very nice. Okay, from kitchen or yeah, very nice guys. So this is the first part of this video. The rest will be very boring, so you can just stop here. Okay, guys, so now let's think about processors. Okay, so um, for this one, I want to show like some chat GPT. So um, assembly sample. Okay, so basically, I know that one command is doing one thing. Okay, I mean, there is, I mean, yeah. So basically, processor is going through this code, right? So how he does this? First question, right? So this code um, is stored somewhere. Okay. So so we need to understand how, by the way, data is stored. Okay. Of course, we know that it can be stored like there was like some vinyl players. I'm talking about this stuff. So of course there were some mm, magnetic tape. This one, if you are old, also maybe you know floppy disk. Then maybe DVD. Then flash drive. Then SSD. Of course, HDD. And that's all, right? I think that's all. So all of those that I showed you is some uh, possible ways of storing data. So for instance, our processor needs to get this data uh, and understand. So for example, so how the data is stored is simply right by zeros and ones. So in some cases, in HDD and other variants, I think it is the mechanism of specific storing those information, and information is like one or zero, is pretty different, I think. Um, but so they all have one connection, like not like, I mean, for example, USB, right? So everything USB is understands USB. So the same will goes for SSD, HDD, and other stuff. So they all connect somehow to our processor, and our processor somehow reads data. So for example, our processor read this data. Okay. So he needs to understand what this command what he needs to do, right? So processor needs also some memory, of course not this, because this is like user memory, but processor itself needs also some memory, but his own memory that will store, for example, information about each command. Okay, and the commands that assembly have are limited, so that's why we don't need to exceed this storage a lot, and any sometimes, so it can be stay the same, and it can be small because we have like limited list of commands. Okay, so what is happening? So processor reads data from storage. It understands what this data means using his own storage, and after that he basically executes what is needed from here. Okay, but this is logically right, and basically this is how all programming languages work. uh, but I actually am interested in the mechanism, the actual mechanism. So I understand that this device, for example, having ones and zeros, okay? So the processor reads those ones and zeros, but how he does it and how he takes decision of which command to run, etc. And I believe these questions are all answered by electronics, and by electronics I mean not basic electronics, but some circuits, some the stuff. Some I heard that like processor has a transistors, like if you say how many. Well, first, what is transistor? Fundamental electronic used in almost it belongs to category turning a current on or off in response to a control signal. So yeah, so it's like a switch. So it's like if statement can be right. So and processors, I believe, have a lot of them. How many transistors approximately in a processor? Okay, so the approximate is okay. It says 16 billion transistors. Billion, right down. Billion in full. In digits, please. Okay, so this is the number of a transistor. This is the numbers of a transistor. So thousand, million, billion, trillion, or I don't know. It's called billion. Okay, again, thousands, millions, billions. Okay, but what is actually a transistor? So yeah, by the way, is transistor how to say that? Is the transistor is the main component in CPU? Okay, but I think they are like the biggest. Okay, never mind. So transistor, what is transistor? Okay. So yeah, so I have a question right now, right here, right now. So here is a transistor. So how does a processor, which is like less than my hand, right? How does it have this 16 billion? Okay, so however, advancement in semiconductor manufacturing technology. What is it? Semiconductor manufacturing technology. Um, what is it? What is semiconductoring? Anyway, I think it's just fabrics, right? Who made it? Factories. Miniaturization enabling manufacturers to pack an ingredient on the single integrated circuit while keeping the overall size. So how they do it? An observation. Intel co-founder Gordon Moore states that the number of transistors on a dense integrated circuit tends to double approximately every 2 years. Okay. Semiconductors continue fabrication process to create transistors and at smaller scales, FinFET and 3D. Okay, I don't know how exactly they do it in CPU. I think we will not see them, right? Okay, so we have this statistic. Intel's 7 nanometers and 5 nanometers process nodes, which are expected to further shrink transistors and improve performance. Today's leading edge achieved transistor feature sizes well below 100 nanometers. Mm, okay, okay, so it's less than 1 meter, like 1, 2, 3, 4, 5, 6, 7. Oh my god. So it's 1 meter divided by 70, right? No, 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 no. 1 meter divided by a lot of zeros, which is 1,000 million. Wow, 1 million. It's quite okay, but it's quite not obvious in meters, in centimeters. Wow, but it's the same number, no? No, it's not. Wow, yeah, it's really in millimeters. In millimeters, I can imagine it is very tiny. Just like this. Wow, come on, guys. I don't understand how you did it. I mean, it's crazy, guys. How you did it. Crazy. Really crazy, guys. How is this possible? I don't understand. Okay, okay. But that's how life is, you know. Life is strange, you know. Phew, guys. I don't understand. Okay. Something with light. Okay. It's astonishing, to be honest. So basically using some microscopes, I mean it's really, I mean it's obvious, right? So for instance, we have a wire. A wire is just thing that passes electricity, right? But we can have a thick wire, we can have a small wire. It doesn't really matter. Both of them will pass electricity, of course, different amount, right? Or something like that. So in theory, we can make this wire smaller and smaller. I mean, of course, we cannot do it smaller than like molecule, one atom, right? But in theory, we can do it like one atom, right? Or no? Or plus minus this stuff. Okay, and we use, for example, some technologies, right? I don't know which technologies, but some science technologies. And this is possible because, microscope, right? If we can see small things, of course, we can manipulate with them, right? So that's pretty logical, okay? But I don't understand how we can work on these small things without small. I mean, for work with small things, we need some small tools, right? But um, yeah, and that's strange. How we can make small tools with the big tools? Can we make it? Maybe yes. Maybe yes. Yeah, I think it's possible in theory. So in theory, we just smallerize our tools, and in result, we can manipulate on a smaller level. Okay, okay, that's cool. But again, I don't know. Imagine what will happen if, I mean, there are new, there are CPUs development. Okay, at this time, so CPUs are everywhere, right? So I don't know. I will go to Rosetta UA, okay, and I will search for a CPU. Okay, it was there, but anyway, processor, okay, processors, CPUs, and I will go to Novinky, newest. Here, this one, for example, it was published. Mm, Anyway, it was published recently, right? So somebody is creating those things. So I just wonder what will happen if those people, for example, die. What will happen? Like so who will create those things later on? Okay, so I guess the question is pretty simple. Uh, so companies or people who are making those stuff, they make sure to hire new people and they teach them how to use tools that uh, they have, so that people will continue to use those tools. But anyway, I mean, there are some people who invent even smaller tools. So I have a question: what if they will die? I don't know what will happen. That's well, maybe they also teach some new guys, young guys, how things work and how do they make that stuff, and pass their knowledge to them. Maybe this is the case. Anyway, I think this knowledge is really private. So actually, we don't have it in universities. I think so, but I'm not sure. And yeah, I think so. We don't have it in universities, so it's like more private one. And it's obvious, right? Because how you can learn things without even touching them, and actual tools are on those companies like AMD or Intel, right? So in order to learn it, you will actually need to to have it at hand, right? So that's why. So okay, we're definitely we will not be without this CPU. So definitely it will grow, and in future we will continue to develop it and blah blah blah. Okay, that is a good answer, but I had another answer how actually CPU works. So okay, but we understand that transistor is giving us if, right? So we can actually make a decision. Okay, so if we can make a decisions, then probably we can program anything, right? So we can program CPU to, for example, when we see this assembly code, where is it, blah 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 blah. So when we see this, for example, command, then we do this and this. Okay, so transistors can answer my question basically. Okay, that's great. I don't really know how to work how transistor work, but anyway. Um, okay, I have asked something here. Yeah, so there is also arithmetic logical unit. Well, it's like another kind of CPU, right? That just performs some. It's just a functions basically for CPU. Registers, so it's like a storage unit. Okay, it's like a storage that CPU uses for temporal things. Control unit. The control unit manages the execution of instructions by decoding and coordinating the flow of data between various CPU components. Okay, so this is like some coordinator. Okay. Cache memory. CPU include various level of cache memory to store frequently accessed instructions and data. Okay, this one is cool because I note that I mean, first of all, it's about optimization. So there are guys specifically in C++ that actually care about this stuff because you'd want if you go for a loop you want the stuff to be in cache memory, okay, so it will save a lot of time, uh, but again it's just another storage in CPU. Memory management. MMU handles memory related tasks such as virtual memory translation, memory protection and caching of memory contents. Okay, so it's just another functionality. Clock and timing. CPU have clock generators and timing circuits to synchronize operations and maintain proper timing for instruction execution and data processing. Well, this one is interesting one. So this is really some physical stuff. So first physical stuff is this transistor, and second is clock and timing circuits. Bus interface. CPUs interface with external devices and components, memory through buses, data bus, address bar, control bus, transfer data. Okay, so this is another functionality. Okay, so I have two questions. What is a transistor and how does work, and what is a clock and timing circuits? CPUs have clock generators. Oh my god. Clock generator. What is clock generator? Okay. Oh, I think I see it. You know this characteristic like this, right? Gertz, you know, number of Gertz. So I think this is the clock generator basically. So it is an electronic that produces a clock signal for use in synchronizing a circuit's operation. Yes, yes. So it's just so it basically says to change a command. I don't know, something like that. Interesting. Okay, but how it works, I don't understand. Um, Timing circus. I don't think timing circus is a great stuff. Oh yeah, I don't think it's a great stuff. Okay, so first, what is a transistor? Just simple transistor, not in a. We know that in processors they're extremely small, but in general, what is a transistor and what is a clock generator? So I hope here will be, oh nice, a desktop PC clock generator based on the chip IC. Oh my god, too hard for me. Really too hard. Okay, so here we have some scheme. So uh, obviously it is like some physics going on. So It has not some functionalities inside here, it's just some physics. So by using some metals, semiconductor and other blah 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 stuff, it is working with elements, electrons, I think that stuff. But this stuff is different. It's like real cheap, right? So it's like real cheap. Cheap. What is cheap? Because cheap maybe also is. Yeah, yeah. Okay, guys. I think you know what we can say that clock generator is actually a CPU itself, some kind of, because I mean its function is just to create signals. But how does it works? The signal, blah blah blah. Oops, sorry guys. The resonance is usually quartz piezoelectric oscillator. Also simpler tank circuits. Okay, so, but how does it work? Is the electric charge that accumulates in certain solid metals such as crystals? Okay, so I don't know. Do you know this about this? But I think if there is some energy, right, electrons is going on. So this thing can just pass those electrons with some delays, right? Using some techniques such as how it's called, condensator. I don't know how to say it in English. Mm, Yes, so this one. So basically it charges and then it uncharges. So, and you can create like some blinking without it. So I think if I, no, yeah, I think so. This one is the base of this one. So I hope so. And this one is base of CPU, and transistor also uses this one, but also he uses some memory management, and memory management is just ones and zeros, and how they goes to us is not understood to me. So okay, we have like bunch of zeros and ones, but how do we read them? I mean, okay, we can read first one, but how we know that we need to read second one? It's hard. It's really hard. But maybe we read them one by one. Okay, yeah, that's easy solution. Okay, guys, so I think that's all. I mean, I I I got a little knowledge about what is a CPU and a little knowledge about how it works. Um, so I think that's all. Yeah. Um, Put a like, place a comment, and subscribe and share this video among the world. Bye.